This marks our last video on parabola and quadratics. Now, in this video, we are going to tackle two main concepts. First of all, we are going to learn how to convert the equation or the function of a parabola from the factored form to the vertex form. And then also, we are going to learn how to choose the correct form of a quadratic equation for specific solutions. The reason why this is important is because usually in the SAT, um, you are given, sometimes you are given certain parameters to find, and you are asked to select from the alternatives which of the forms of the quadratic equation would be more suitable for um, the solution you are looking for. So let's start with the first one. So we're going to give an example. So let's say you have an equation of a parabola or a quadratic to be in the factored form. Let's say x minus 3, okay, x minus 3, then x plus 5, okay, x plus 5. Let's say everything multiplied by 4. So usually you get it in this form. If you are lucky, your a here would be 1, and so there will be nothing here, which will make the work easier. But in this case, this is what you do. First of all, you have to find the roots quickly. You deduct the roots. You deduce the roots from here. In this case, the roots is 3 and negative 5. Okay, 3 and negative 5. Now, after getting the roots, you now find the average of the roots. So you add the roots and you divide by 2. And this would give you what? Negative 2 over 2, which is negative 1. Now it means this gives us the x coordinates of the vertex. Listen, the x coordinate of the vertex. Okay, so our vertex is negative 1. Now to get the y coordinate, you just substitute negative 1 into this, and then the value will be our y coordinate. So here, negative 1 here will be what? Negative 4. Negative 1 here will be negative 4. That's negative 1 minus 3. And then negative 1 here will be 4. So negative 4 times 4 will be negative 16. Then negative 16 multiplied by another 4 would be negative 64. Okay, it would be negative 64 if I'm right. So it means our y value is negative 64. So this is our vertex here. This is our vertex. Now, immediately we have our vertex, we can write our equation now in the vertex form, okay? Which would be, first of all, you write your a here. You write your a here. You write your a here. So start by writing your a, which is 4, multiplied by, in the vertex form is given by something like this: a multiplying x minus h all squared, then plus k, right? Now, the h here is our negative 1, and then your k is negative 64. So you just put it inside. So a is this. So x minus your h, which is negative 1, so plus 1. Then plus negative 64, which is negative minus 64. So this is our answer. Very simple. So how did we do it? First of all, you find the roots, you find the average of the roots. After finding the average of the roots, that gives you the x-coordinates of the vertex. You substitute it into the original equation or original function, now giving us the y-coordinate. Now with the y and x coordinates of the vertex, you can now write it in your standard form with your a value from here. So to summarize everything, first of all, given that a and b are the roots of a quadratic equation, which can be gotten, which you can get from the standard form or from the factored form, any of them. So far as you have the roots, first of all, so you just find the average of the roots, okay, average of the roots. This will give you the what? The x coordinates of the vertex. You substitute this into the original equation to get the y coordinates. Then you can write your vertex form right away from there. Now, to recap, when we did the standard form the last time, you remember we said the x coordinate of the vertex is given by negative b all over what? 2a. Now, this is because this is the average of the sum of the roots. Okay. Now, this is the same as this here, if you would get me. Because in the standard form, b stands negative b over a stands for your sum of roots. Negative b over a, sum of roots, and then over 2 will give us the average. Now, we are done with this. Make sure to solve more examples to be familiar with the concept. Now we move to the last concept of the video, where we are going to talk about how to choose the correct form of quadratic equation for any solution you are being asked for. So here, in the question, you are being asked to find the roots or the x-intercept. Now, the form of the quadratic equation or quadratic function that is most suitable to get your root or x-intercept from is the factored form, okay? The factored form. Now, why is this so? Now, let's write a general form of a factored form, which is something like this, x minus a, okay, multiplied by, let's say, x minus b, okay? Now, in this case, your a here will be one root, and then your b will be the other root. So these are the roots of the equation. It is very simple to get it from here. And then also, the roots are the same as the x-intercepts. Okay. So whenever you have a quadratic curve like this, the x-intercepts here and here are the same as the roots of the quadratic equation. Now, the next thing is, from which form is it best to identify your minimum maximum value from? And this is from your vertex form. So your vertex form easily gives out your what? Minimum or maximum value. So your vertex form is a multiplied by x minus h all squared plus k. Okay? Plus k. Now, from here, your minimum or maximum value will be k. Okay? Will be k. And then the value for which you get your minimum maximum value will be your h here. Now the h comma k will now be our vertex. Now the vertex, which means it is easy to determine your vertex whenever you are given also the vertex form. So minimum and maximum value and the vertex. Easy to determine when you have the what? The vertex form. And then the y-intercept, obviously we get it easily from the standard form, which you have ax squared plus bx plus c, okay? Plus c. Now we know the c here is our y-intercept. This is so easy to determine from our standard form for a quadratic or a parabola. Now this brings us to the end of our module on parabola. Thank you very much. See you in our next video.